Ever wonder how self-driving cars really see the road? It's not just about cameras or sensors. It's about understanding the world in a way that's precise, scalable, and smart. Today, we're diving into two groundbreaking papers that are reshaping how we create high-definition HD maps, the digital blueprints that guide autonomous vehicles. Let's start with the basics. Traditional HD maps are like super-detailed road atlases, showing everything from lane markings to traffic signs. But creating them is a beast. It's time-consuming, expensive, and often relies on manual data collection. Enter Himap and Mapprior, two innovative approaches that use AI to automate and improve this process. So what's the big idea? Himap, developed by a team including Zhou, Zhang, and others, uses something called hybrid representation learning. Think of it as teaching a computer to see the road in two ways at once, pixel by pixel, like a camera, and vector-based, like a scalable, data-efficient blueprint. By combining these, the system can generate ultra-precise, vectorized HD maps end-to-end, meaning it skips the messy middle steps. It's like turning a photo of a street into a digital road map in one go. Meanwhile, Mapprior takes a different angle. Researchers like Zhu and Zarianov used generative models, AI that's great at creating new data, to predict road layouts from limited inputs. Imagine giving a computer a blurry image of a highway exit, and it fills in the gaps, drawing lane lines, sidewalks, and even traffic rules. This approach is especially powerful because it can work with sparse data, making map creation faster and cheaper. But here's the catch: no system is perfect. PriorFusion, another promising technique, relies on dataset-specific priors, meaning it needs retraining for new environments. If it encounters a road layout it's never seen before, like a quirky urban design, it might stumble. And while it handles most shapes well, some complex curves still trip it up. The team even tried advanced tools like VAEs, think of them as shape encoding AI, but hit roadblocks in implementation. But here's the exciting part: the researchers are already planning upgrades. They want to make Prior's cross-scenario adaptable, so a model trained in Tokyo could work in Paris. They're exploring better ways to handle nonlinear shapes and even merging diffusion models with vision language models, like AI that understands both images and text, for smarter, more flexible mapping. So why does this matter? These advances aren't just about robots. They're about smarter cities, safer roads, and a future where technology understands the world as intuitively as we do. HD maps are no longer static snapshots. They're dynamic learning systems that adapt in real time. For self-driving cars, this means navigating construction zones, sudden detours, or even a rogue skateboarder with confidence. Let's circle back to PriorFusion, the method that's making road perception smarter. Traditional systems struggle with shape fidelity, often missing subtle curves or misinterpreting irregular shapes. PriorFusion solves this by using shape priors, pre-learned knowledge about common road structures. In visualizations, red marks road boundaries, yellow are lane dividers, and blue highlights pedestrian crossings. The orange areas show where older methods fail, like missing sharp turns or misclassifying shapes. But look at the green areas, PriorFusion's improvement. It creates smoother edges and clearer turning points, like a roadmap that adapts in real time. How does it work? The magic lies in its efficiency. PriorFusion uses a truncated diffusion strategy. Think of it as a shortcut. Instead of complex, time-consuming steps, it achieves 7.98 frames per second with just 2 decoder iterations. That's fast enough for real-world driving. Plus, adding its shape prior module doesn't bloat the system. Runtime and parameters stay lightweight. It's like upgrading your GPS without slowing down your car. Breaking it down, first, PriorFusion uses an instance-aware attention mechanism. Imagine a spotlight that highlights road elements based on their shape. If the model sees a line, it knows, hey, this is probably a lane marker, not a random blob. Next, it builds a low-dimensional shape template space, a library of road element blueprints. By clustering real-world data, it creates reference points, called prior anchors, that guide the model. It's like having a cheat sheet for road shapes, ensuring predictions stay consistent and accurate. Finally, it uses a diffusion-based architecture. Think of it as a painter refining a sketch. The model starts with a rough outline and adds details step by step. This creates smoother, more precise road elements, even in tricky scenarios like crowded intersections. The results: PriorFusion outperforms existing methods, especially in complex environments. It reduces errors, sharpens boundaries, and even retains critical details like sharp turns. And here's the kicker: it's efficient enough for real-time use, which is a huge deal for self-driving cars. So what's the big picture? By combining prior knowledge with cutting-edge AI, these techniques are making roads safer for autonomous vehicles. It's not just about better tech, it's about building trust in the future of driving. Thanks for watching. If you want to dive deeper into how AI is reshaping mobility, hit that subscribe button. And drop a comment: what's your take on self-driving cars? Let's chat.